So let's go ahead and demo objects using a real live programming language. Don't worry if you don't know how to program yet or aren't quite sure what's going on. Just trust me and do your best to follow along. So let's start off by looking at what we're doing in this demo. Imagine we're coding a super simple dog simulator game, kind of like Neopets, where you're supposed to take care of your pet by feeding them and loving them on a daily basis. And if you don't, they die. Oh no. How can we approach something like that? How can we code something like that? Well, as you may have guessed, the answer involves object-oriented programming because this is a demo about OOP, and yeah. So, yeah, let's look at this program. As you can see, we have these things called classes at the very top of the program. And classes are simply the types of objects that we're creating. In this case, we're going to have two types, okay? A dog and a food type. That's it. That's all we need for our super simple simulator. So let's go ahead and start coding by using these classes to make objects. Let's make a new dog. Let's make a new dog. And we're going to name him Sparky. And this dog's name is Sparky. And he's a medium-sized dog. And his owner is Kunal. That's me. The next thing to do after we made our dog for the person, joining our simulator will be to actually simulate some time going by. In Neopets, your dog gets tired and hungry over the course of a day, and that should be just as true in our simulator as well. So let's simulate one day. Okay, so we're going to simulate one day for Sparky. Cool. Now that a day has passed, if we're good owners, we should probably check if Sparky is getting hungry. If he is, we should probably make him some food and then feed it to him. Okay, so let's check if Sparky is hungry. Now, we have this awesome food class that we can use to make food, and a dog object will need that food to survive. So the key point here is that objects can interact with each other and communicate in a way with each other. So let's feed Sparky. Or let's actually just check if Sparky is hungry. And we should feed him if he is. If we should feed him. Cool. So Sparky food is going to be some food object. If Sparky is hungry, well then Sparky will need to eat some food. Okay, so all this is doing is we're creating some food, we're buying some food for Sparky, and if Sparky's hungry, well then we're going to eat some food. And this actually needs to be this. Okay. So you'll see in that last line, I wrote that Sparky should eat the object that's called Sparky food. And this shows that our dog object and our food object are really, interacting and communicating. If Sparky can eat food, if a dog object can eat a food object, well, that means that objects can communicate with each other. They're doing things together. For a better look at this, let's zoom into Sparky and see what's going on when he performs that eat action. What's going on? So let's go to dog. And within dog, we have all these different actions that they can do, right? In it is it's just them making themselves. They can bark. They can, perform a trick. They can eat. And you can check if they're hungry as well. So within eat, what's going on? Well, food is coming in, okay? And the food comes in, and its energy becomes the dog's. So that makes sense because that's how food works, right? You eat food, you get energy from the food. And then Sparky's happy. So that's pretty awesome. Essentially what we see here is that Sparky eats that food, and cool. We've done a quick demo that takes a look at some objects interacting with each other in our dog simulator, and there were no graphics and the program isn't very long or complex, but it is a simple dog simulator and it does work. So when would this be important? Why are all these things, being boxed up important? This is abstraction. Earlier in lecture, we said that OOP was, it would work by defining each piece of the program without worrying about how all the other pieces would fit together. And then just at the end, once everything has been created, having them work together. So if I'm working on a much more complicated dog simulator, and I'm working with a team of other programmers, we're going to be abstracting away all the details. Let's say one person is working on what gets simulated in a day. So currently what gets simulated in a day is the dog barks twice and he does a trick. And, what happens when a dog barks? Well, they lose some energy. When they do a trick, they lose a lot of energy. They also print woof. It starts to get really, really complex. So we don't want to share the details of exactly what we're doing. We're only going to be sharing the important details, like that a dog can eat, that Sparky has an eat, action that he can perform, or that food has, some energy, because when I'm making my eat function over here, I want to know that food has some energy and that I can make that a part of my energy as well, or my dog's energy. Now, since we're all going to be working together and not sharing the details, that's going to be the key tenet of abstraction and the important part of object-oriented programming. And we'll take a look at some more examples to solidify how objects work together and interact with each other. But hopefully that was a nice, quick demo.